Hi guys, today we will solve operators challenges with an explanation, so let's start. Let's solve the first problem. In the first line, Python uses the AND operator. This is a bitwise AND, not a logical AND. Bitwise AND works on numbers before comparison, so Python first calculates 1 and 0, which is 0. Then the expression becomes 0 less than 0 less than 2, which is false. In the second line, the AND keyword is a logical operator. Python simply checks both conditions. Since 0 less than 1 is true and 0 less than 2 is also true, the final result is true. So output is false, true, in separate lines. Okay, now let's solve. Second problem. Here we are using the round function. Python follows a rule called round half to even. This means when the number ends with 0.5, Python rounds it to the nearest even number. So 2.5 becomes 2, 3.5 becomes 4, and 12.5 becomes 12. This behavior helps reduce rounding errors in calculations. Okay, let's solve next problem. In this example, Python uses a chain comparison. Instead of checking two conditions separately, Python checks them together. First, it checks if 5 is less than 10 and 10 is less than 15, which is true. Next, it calculates the modulus. 15% 10 gives 5, which matches the value of x. Since both conditions are true, the final output is true. First we have x equals 5 and y equals 3. And we also have their binaries. Now let's apply each operator, and only gives 1 when both bits are 1. So after applying AND, we get result 1. Next OR gives 1 when any bit is 1. So after applying OR, we get result 7. Next, XOR gives 1 when the bits are different. So after applying XOR, we get result 6. Last NOT, bitwise NOT flips every bit. The simple formula for NOT is (x equals x plus 1), so approximately 5 equals 5 plus 1 equals minus 6. That's why the output is 176 minus 6. Next, we look at shifting. We take a equals 8, which is 1000 in binary. Shifting it right by 2 removes 2 zeros from the end, leaving 001, which becomes 2. For b equals 3, which is 0011, shifting it left by 2 simply adds 2 zeros at the end. This becomes 1100, which is 12. So this line prints 2 and 12. Now let's look at Python's is operator with the numbers 256 and 257. Python sometimes stores small numbers in memory only once to save space. So when we write a equals 256 and b equals 256, they both point to the exact same memory object. That's why a is b becomes true. But for the number 257, Python usually creates a separate object each time. So x is 257 and y is also 257, but they are stored separately. That's why x is y becomes false. Now let's understand how an AND OR work in Python. First, Python does not return true or false every time. Instead, it returns the actual value that decides the result. When we write 1 and 2 and 3, Python checks values from left to right. The AND operator stops when it finds a false value. Here, all values are true, so Python returns the last value, which is 3. So the output is 3. Next is 1 or 2 or 3. The OR operator stops as soon as it finds a true value. Since 1 is already true, Python returns 1 and does not check further. So the output is 1. Now look at 0 and 2 or 3. Python evaluates this from left to right, and has higher priority than OR. First, 0 and 2 is checked. Because 0 is false, Python returns 0. Now it becomes 0 or 3. Since 3 is true, Python returns 3. So the output is 3. Finally, we have false or 0 or OR. All of these values are considered false in Python. The OR operator keeps checking until it finds a true value. Since there is no true value here, Python returns the last value, which is an empty dictionary. So the output is empty dictionary. Finally, we repeat the same x and y bitwise operations again. Simply apply this formula, minus x plus 1, and tell me output in comments. Hope you enjoyed the video. If it helped you understand the concept, just hit subscribe and I'll see you in the next one.